Hello everyone, good evening, good evening, good evening. I hope I'm audible and visible. I hope आप सब बढ़िया एकदम मस्त एकदम ढिंचाक. So here I am B2A basic to advanced series का एक और session लेके that is on quantum numbers. So in this series we are targeting NSEJS exam. So we are doing all the topics that are very important that you should do if you want to crack NSEJS 2025. So guys, I hope I'm audible and visible. You all can hear me. You all can see me clearly. Yes guys, let me know. Hi Harshit. Hi JEE Hustler. So quantum numbers. So in the last session, I talked about Schrodinger's wave equation, where I also talked about quantum mechanical model and all the information about an electron in an atom is hidden in 4 numbers which are known as quantum numbers. So in today's session, we are quickly going to learn quantum numbers, and it is indeed a very interesting topic, guys. Right, so stay tuned. So if you haven't subscribed our channel yet, Science Olympiad Preparation, do subscribe. Vedantu, Science Olympiad, a different channel. So those who are not subscriber of this channel, and if you are targeting Science Olympiad, be it Junior Science Olympiad or Senior Science Olympiad, or even if you are not targeting any Olympiad, but yes, you are clear that you are going to target JEE and NEET exams in future. So just make sure you are part of this channel, Vedantu Science Olympiad, a new channel launched for science lovers, right? Okay. So this is Vedantu Olympiad School, Harshit. It is Vedantu Olympiad School. The session that I took on mole concept, that was on another channel, that is Vedantu Science Olympiad channel. This channel is VOS, Vedantu Olympiad School. You are getting confused now, guys, right? Okay. So quantum numbers. So quantum numbers are basically set of 4 numbers which will give you the address of electron. As I told you, if you need any person's address, you need city. Right? In that city, you need locality, in which area, in which locality that person lives. And in that locality, you need house number also. And the 4th thing is the identification, how you can identify a person living in a house, because in a house, there can be more than 1 person living, guys. Right? So just the same way, if I have to locate an electron in an atom, right? Then I need 4 numbers which are known as quantum numbers. If I know these numbers, I know everything about an electron. So quantum numbers are like address of an electron in an atom. And from where these quantum numbers came, these numbers are being, decoded or derived from a very complicated equation, mathematical equation, that is Schrodinger's wave equation that I talked about in the last session. I hope you watched that session. And in case you missed that session, please do watch that session, right? So in simple form, the information about an electron is being expressed in terms of 4 numbers. This is a set of 4 numbers which will give you information about an electron. That means its location, probable location, its energy, how far it can be from the nucleus, right? Shapes and everything. So these 4 numbers, right? So just like, so address, we have 4 numbers. First, which will tell you the city of an electron, that is principal quantum number. Second, which is like the locality in that city, area, that is azimuthal or angular quantum number. The 3rd quantum number, which will tell you about the house number, that is magnetic quantum number. So these 3 quantum numbers that derived from Schrodinger's wave equation, and later on a 4th quantum number, that is spin quantum number. It is also being added for the identification of electron. Yes? Clear? So Schrodinger's wave equation, that gives you information in the simplest manner so that any person can understand, because that is a higher order mathematical equation. Not everyone can understand or get the solution of those equations. So the information that those, psi, the wave function or Schrodinger's equation has, that is being decoded in terms of 4 simple numbers which are known as quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So if you know about these 4 values of for any electron, that means you have a lot of information about that electron, right? So let us start with principal quantum number, that is represented by small n. So basically, principal quantum number tells you about the shell of the electron. In an atom, there are various shells. They are just like cities. Like in India, we have various cities, various regions, right? So in an atom, there are various 3-dimensional regions known as shells. So the first quantum number, that is principal quantum number, tells you about the city of electron, or we can say the shell of electron, in which shell the electron is present. And this is the same shell which was talked by Bohr in his atomic model, right? Bohr atomic model. Bohr talked about shell orbit, right? But we are now talking about quantum mechanical model, which talks about orbital 3-dimensional regions where probability of finding the electron is maximum. Nothing is 100% certain. We can only tell about 3D regions inside an atom. So this is the region, this shape, right? This geometrical shape where the probability of finding the electron is maximum. So the principal quantum number can be 1, 2, 3, 4, 5, 6 and so on, right? So n equal to 1 means K shell, n equal to 2 means L shell, n equal to 3 means M shell, n equal to 4 means N shell. So n value tells me the shell, right? First shell will be the most closest to the nucleus. As the value of n increases, the distance between that electron and the nucleus also increases. So I can say the n value tells you about the radius, right? How far that electron is from the nucleus, the size of atom, right? So n, principal quantum number, I will say the most easiest one, right? First shell, second shell, third shell and so on. Now the principal quantum number, right? N. So this information I will share later on with you. Next is azimuthal or angular quantum number, represented by small l. You can see the L there, right? Small l, angular quantum number, azimuthal quantum number. Now, in your atom, there are shells. Each shell has various subshells, right? Just like cities has various areas or localities. So in an atom, there are certain 3-dimensional regions. We call them shells. And each shell, each city, just like each city has various areas or locality, each shell has various smaller regions known as subshell. So this particular quantum number L tells us about the subshell. We reached say shell. So my electron is say in n equal to 2, second shell. Now which subshell of the second shell, right? So my electron is present in which subshell of the second shell, that is being told by azimuthal or angular quantum number L. So the value of L depends upon n. For a given value of n, L is 0, 1 up to n minus 1, right? For a given value of n, so value of L depends upon n value, the shell value. So from 0 you go up to n minus 1, right? So if n is equal to 1 per shell, that means L value is 0. If n equal to 2, what are the possible values of L? 0 and 1, n minus 1 is 1. So you have to go from 0 up to n minus 1 value. N equal to 3, what are the possible L values? 0, 1, 2. For n equal to 4th, you have 0, 1, 2, 3, right? Now, each of these L values corresponds, has a designation, the name of the subshell, right? L values tells you about the subshell in a given shell. Got it? Just like you have city, in city you have various localities and each locality has some name, of course. In city we have various areas, each area has certain name, right? So guys, for L equal to 0, we say it is S subshell. If L value is 1, we say it is a P subshell. L value 2, we say it is a D subshell. L value 3, we say it is an F subshell. And L value 4 means it is a G subshell. right? So now look here guys, for first shell n equal to 1, L is 0, means in first shell you have one subshell, that is S, right? So in first shell you have S subshell. In second shell I have two values, 0 means S subshell, 1 L value 1 corresponds to P subshell. You can see the table here guys, and you have to keep in mind, remember, if L value is 0, then it represents which subshell? S. If L value is 1, that means P. If L value is 2, that means D. If L value is 3, that is F subshell. Got it guys? Yo. Now third shell, 0, 1, 2. These are the possible L values of n equal to 1. That means in third shell I have S subshell, I have P subshell, and L equal to 2 means I have D subshell, right? Similarly, in fourth shell, I have various subshell S, P, D and F. So let me tell you here, first shell has just one subshell, that is S. Second shell has two subshell, S and P. 2S, 2 stands for the shell number, S is the subshell. Third shell has 3S, 3P and 3D, 3 subshell, S, P, D. Similarly, your fourth shell has 4S, 4P, 4D, 4F. And your fifth shell will have 5S, 5P, 5D, 5F, 5G. Got it? So, in each shell, we have various number of subshells. Yes, S, P, D, F. G also, right? Yes, and these subshells has various different shapes. They are the regions inside an atom where the probability of finding the electron is maximum. Just like you know, in India, we have so many states, and if you see the map of India, the shape of each state is shown there. The area, how far, far it is in kilometer, right? Its territories and all. So if you see Indian map, you can see the shapes of various states. What are states? They are the areas, they are the 3D regions. Same, in atom you have various regions, we call them shells, and each subshell we have smaller 3-dimensional regions each having particular shape. They are known as subshells. Got it guys? Yes. And so what is the shape of S subshell? The shape of S subshell, if it is a S subshell, L equal to 0. So S subshell, when it is S subshell, when L value is 0. That shape is spherical. Shape is spherical. So for S subshell, that has a spherical shape, right? Yes. P subshell. When is P subshell? When L value is 1. Azimuthal quantum number value is 1. That shows it is a P subshell. And the shape of P subshell is like this. This is dumbbell shape, right? It is dumbbell shape. D, when L value is 2, that corresponds to D subshell, and the shape of D subshell is like this. This is known as dumbbell shape, right? And if L value is 3, that corresponds to F subshell, and it has more diffuse, more complicated, complex shapes. Yes, definitely Sambodhini. Okay, so guys, S, P, D and F, these are the subshells present in the different shells, right? And each has different shape. Got it guys? Yes. So this L value, if you know the L value, right? Yes, so you can calculate the angular momentum, because the electron is, spinning also, right? The angular momentum of an electron. This is the formula. Under root of L plus 1, H is the Planck's constant by 2 pi. Many times questions have been asked on this. Let me give you an example. For example, my electron is present in 3p. That means third subshell, third shell and P subshell. So this number tells you about the shell, principal quantum number N, this is, and this tells you about subshell. That means this is angular or azimuthal quantum number. So your electron is present in P subshell. Now for P, L value is 1, L0 means S, L1 means P. Now put the value. L is 1 here, 1 plus 1 h by 2 pi. So under root of 2 h by 2 pi, this is the angular momentum of an electron present in 3p. Right? Got it, guys? So if electron is present in 3p, that means it is in which subshell? P subshell, right? L is equal to 1. So you can use this formula to calculate the angular momentum of that electron. Right, guys? So in atom, we have shells, which is denoted, which is expressed by principal quantum number. In each shell, we have various subshells, which is being expressed by azimuthal quantum number L. Got it? Till here, I hope it is clear. Now, each subshell, each locality has various houses. So if I want to meet a person, I want to locate a person, I should know the house number. So similarly, in subshells, we have various orbitals. Orbital is a three-dimensional space where probability of finding the electron is maximum. That means orbital is the घर of electron, जहां वो रहता है, पाए जाने की संभावना is maximum. Right? Aditya, that is why I kept this B2A series at 9 today, because I know there is Akar batch session on Vedantu Science Olympiad. The timings that we follow for B2A series was 8 p.m. before. Now it will be at 9 p.m. just to avoid the clash between Akar batch sessions and the B2A series session. Got it? Okay. But make sure that you all are present on that Vedantu Science Olympiad channel also, because we are going to give you the more content, Science Olympiad specific content on that channel. Okay, guys. So, third quantum number is magnetic quantum number, that is being represented by M. So, let me brief you. What is M? M tells you about the home of electron. So, you have shell. In shell, you have subshell. In each subshell, you have various houses, that is orbital. So, the first quantum number tells you about shells and which subshell of the shell and which orbital of that particular subshell, right? The orientation of electron in a subshell. The electron is present in which orbital of the subshell. So the value of M depends upon the value of L. As I already told you, the value of L depends upon the value of N, right? So now let's see what is the value of M for a given L. For a given L value, given L, the M value is from minus L up to 0, then up to plus L. For example, your L value is 1. That means P subshell. That means what are the possible values of magnetic quantum number? You will go from L, minus L to plus L with 0, right? Minus 1, 0 and then plus 1. Suppose L value is 2, that is the subshell. What are the possible values of M? Minus 2, minus 1, 0, plus 1, plus 2. So that means you are supposed to move from minus L to 0 and then 0 to plus L. Got it? Yes. That means for a given value of L, the total values of M, possible values are 2L plus 1. Right? 2L plus 1. Right? For example, let's take an example. Let me brief you here. Let me make it more clear. Now you have shell, you have subshell, and you have, this is shell, this is subshell, and this is orbital, magnetic quantum number. First shell, what is the possible value of L? If N is 0, L is, if N is 1, L is 0. That means in first shell, I have just one subshell, that is S. And of course, the value of M is also 0. Now in second shell, I have 0, I have 1. These are the two possible values of L. That means in second shell, I have S subshell, I have P subshell. L value 0 means S subshell, L value 1 means P subshell, right? Abhi will get there, Aditya. That means what are the possible values of M? If L is 0, M is also 0. If L is 1, what are the possible values of M? -1, 0, +1. Now let's get back to the third shell. Third shell, N is 3. What are the possible values of N? 0, 1 and 2. That means third shell has S subshell, P subshell, D subshell. Now third shell, S subshell, 1 M value. -1, 0, +1. 3 values possible for M. -2, -1, 0, +1, +2. So minus L to 0 and then 2 plus L. Right? Now let me decode it. First shell has one subshell, that is S subshell. And in S subshell, we just have one value. I'm saying number of values. I'm not saying what is the value. So I have just one value. That means in one S, I have just one orbital, because M value, the number of M values possible is equal to the number of orbitals. जितनी M की values हैं, number of values is equal to the number of orbitals in that subshell. What is orbital? Orbital is a three-dimensional space inside an atom where the probability of finding the electron is maximum. Our quantum mechanical model is a probability-based model. So we cannot be 100% certain about the location of electron inside an atom. I can be probable and I will define the regions where the probability of finding electron is maximum as my orbitals. Got it? So guys, now let's have the second shell. So I have second shell. In second shell, I can see I have two subshell, 2s, 2p. In 2s subshell, I have only one M value, 0. That means I have just one orbital in 2s. Whereas 2p, I have three values. These are the 1, 2, 3, 3 values. That means in 2p, I have 3 orbitals. The number of values of M is equal to number of orbitals. Now in third shell, I have 3s, I have 3p, I have 3d. In 3s, I have one orbital. In 3p, because I have 3 values for M, because number of values of M tells me about the orbitals, 3 orbitals, and this, that is 5 orbitals. Got it? Yes? Done? Similarly, for fourth shell you can do. So it will have 4s, 4p, 4d, 4f. SPDF, because 0, 1, 2, 3. And in S you will have one orbital because you will get just one value for M. In P you have 3 orbitals. In D you have 5 orbitals. In F you have 7 orbitals because 7 possible values for M. Yes, so shell has a subshell. Each subshell has orbital. In those orbitals your electron lives. Right? In those orbitals electron live. So please see this slide. Can you say any S subshell, irrespective of the shell, it will have one orbital. So first shell S subshell, one orbital. Second shell S subshell, one orbital. Third shell S subshell, one orbital. Right? Similarly, P subshell of any shell will have 3 orbitals, 3 ghar, 3 houses, 3 dabbas. And in those houses orbitals, your electron will be filled. Right? And the D subshell, guys, D subshell will have 5 orbitals, 5 values of M are there. F has 7 orbitals. Right? Got it? So let me clear it once and for all, because this is the basic thing and you are supposed to know if you want to write the electron count. 1s, first shell has just one subshell, that is s, it has one orbital. 2s, second shell has 2s and 2p subshell also. 2s has one orbital, 2p has 3 orbitals. Now your third shell has 3s, one orbital, 3p subshell is also there, which is having 3 orbitals. 3d is also there, which is having 5 orbitals. Right? Similarly, your fourth shell will have 4s, 4p, 4d subshell and also the 4f subshell. 4s, s subshell has 1 orbital, p subshell will have 3 orbitals, d will have 5 orbitals, your f will have 7 orbitals and g will have 9. 1, 2, 3, one more. Right? Got it? Done? So shell has subshell has orbitals, and in these orbitals your electron stays, right? And in one orbital, how many maximum electrons I can fill? In one orbital, one dabba, one ghar, how many maximum electron I can fill? That is 2. 2 maximum electrons I can fill in one box, one orbital, right? Maximum electron can be maximum 2 electron, guys. Maximum 2 electron can be filled. Now let's check one by one. First shell. Your first shell has just one dabba, because it just has a subshell. In that S subshell, it has just one orbital. That means in first shell, you can fill maximum 2 electrons. Now let's come to second shell. This is second, this is second, these are second shell. So it has 1 box, 2 box, 3 box, 4 box. Total 4 box. 4 orbitals in second shell. 1 orbital in S and 3 in P subshell of the second shell. That means in total, I can fill 8 electrons in second shell because it has 4 orbitals. Right? Now let's come to third shell. Third shell has 3s, 3p, 3d. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 orbitals in third shell. That means total I can fill 18 electrons in third shell. 2, 8, 18. Do you remember the configuration? The Bachpan wala configuration that we used to study in class 9. This is the more detailed, the exact version. How the electrons in first subshell are arranged, second subshells are arranged, right? Now in fourth, can you tell me how many electrons I can fill in fourth? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 orbitals all in the fourth shell. You can see the fourth number. So 16 orbital, that means total 32 electrons can be filled in the fourth shell. Very well done, Aditya Raj. Got it, guys? Yes. So I hope it is clear how this 2, 8, 18 comes. From SPDF, each shell has various subshells. In subshell, we have orbitals, and those orbitals, the electrons are highly probable to be there. Right? And this SPDF comes from sharp, principal, diffused, fundamental. S stands for sharp, P, principal, D, diffused, F for fundamental. From there, this SPDF, they comes. Yes, got it? So these are quantum numbers. The first quantum number N tells you about the shell. The second quantum number tells you about the subshell. The third quantum number tells you about the orbital of that subshell. Now, these 3 quantum numbers, they were derived from Schrödinger-Baba's equation. And the fourth quantum number, that is the spin quantum number, is used for the identification of electron. As I just told you, in an orbital, I can fill maximum 2 electrons, right? What is happening, guys? So, in an orbital, I can fill maximum 2 electrons. So, for these 2 electrons, I have 2 electrons in the same house. They have same shell. Just like you and your siblings living in the same house. You and your sibling living in the same house. That means for both of you, the city is same, the locality is same, the house number is same, but your parents give you different names, but you have different face, features and all, so that you can be identified. Suppose two exactly same, looking alike, same name person living, true, identical twins with the same name, living in the same house, same city, same locality, same house number, and they look same, the name is also same. How can you differentiate? So in an orbital, I can fill 2 electrons. Now in orbital, 2 electrons can be there. Now both of them belong to same shell of atom, same subshell of atom, same orbital of atom. Now how to differentiate these 2 electrons? For differentiation, we use the 4th quantum number, that is spin quantum number, also represented by s, small s. Right? So the spin quantum number tells you about the spin. So I have 2, 1 khopadi up, head up, 1 head down. So I will say this one will have plus half spin, any plus half spin, and another will have minus half spin. At least their spin quantum number value is different. They have same value for N, L and M, but any one can have plus half, any one can have minus half. So basically, if there are 2 electrons, one is plus half, another is minus half. So the 4th quantum number, that is spin quantum number, is at least different for these 2 electrons. Right? I can differentiate. Spin up, spin down, you can say spin is, you can give plus half to this also, but if this is plus half, the other will definitely minus half. Right? Yes? So guys, 4 quantum numbers, all the information. N tells you about the shell and the energy. How far is electron from the nucleus? More close electron to the nucleus, lesser is the energy of electron. Right? If N value is more, that means the electron is far from the nucleus. That means there is a less force of attraction between the nucleus and electron. So less attraction means more energy. So basically the first quantum number N tells you about the shell, size and energy of the electron. Second quantum number tells you about the shell. Third quantum number tells you about the orbital. And the spin quantum number tells you about the spin. So Aditya Raj, you have 2 electrons in the same orbital. You can give plus half to any, minus half to any. Right? Just fixed values, plus half, minus half. No other value. You are supposed to use these values only. One is plus half, another is minus half. Got it? Spin up, spin down, you can say. Now, the number of subshell in nth shell is equal to n. If you have first shell, you have 1 subshell. If you have second shell, you have 2 subshell, S and P. If you have third shell, you have 3 subshells, S, P, D. That means the number of subshells in shell is equal to the shell number, right? And the number of orbitals in a subshell. Each subshell has orbitals, that is equal to 2l plus 1. So maximum number of electrons that you can fill in a subshell. These are the orbitals. Each orbital has 2 electrons. That means how many electrons you can fill in a subshell? That is twice of 2l plus 1. Maximum electrons that can be filled in any shell is equal to n square. N is the shell number, right? To n square. Maximum number of electron is 2n square. And maximum number of orbital is n square. So each orbital can have 2 electrons. So electron is 2n square. Got it, guys? So basic terms, basic formulas, but very useful. Are they 3? If you have n equal to 3, that means you have third shell. How many subshell it will have? N is 3. Third shell. How many subshell? 3 subshell. What is the number of subshell is equal to the number of shell. That means it has 3 subshell. What 3? One is S, another is P, another is D. Got it? If you have 5th shell, it will have 5 subshells. S, P, D, F, G. Got it? So indeed a basic important information that you should keep in mind, guys. Now let's have question. Which of the following representation is impossible? You are supposed to check the values. Let me tell you once again. If n is this, L is can be 0 up to n minus 1. And for any given L, m value is minus L up to 0, then up to plus L. So let's check one by one. If n is 3, can L be 2? Yes, of course, because for n equal to 3, L value can be 0, 1 and 2 up to n minus 1. And m value can be minus 2, minus 1. So this is correct. So you are supposed to find out the impossible one, which is not possible. Let's check. Very good, Atitri. So C option, guys, please check. If n is 3, L value can be 2, because if n is 3, L can be 0, 1 and 2. But if maximum value of L is 2, can m be minus 3? No, because if L is maximum 2, m can be minus 2, minus 1, 0, plus 1 or plus 2. So m value cannot be minus 3. M value cannot be minus 3. That means this option is impossible. So for S, you just need to check. If it is written plus half or minus half, any will be okay for an electron. Right? S is fixed. Spin quantum number is fixed. Even if it is written plus half, then also it is fine. If it is written as minus half, then also it is fine, guys. Now the next question, let's have a look. Which of the following statement concerning 4 quantum number is false? N gives you the idea of size, L gives you the shape, M gives you the energy of electron in the orbital, MS gives you the direction of spin angular momentum of the electron. So which is not correct as per you? Of course, N value tells you about the energy. This MS, well, this is basically MS value. What it tells you, guys? M value tells you about the magnetic quantum number value tells you about the orientation or the shape of the orbital basically. And spin quantum number tells you about the spin, right? So this is not correct. Spin quantum number doesn't tell you about the energy of electron. This is false. Next, how many electrons can be filled if n is 3? N is 3 means third shell you have. L is 2. For L equal to 2, remember L 0, 1, 2, 3. If L is 0, that means S subshell. L is 1, P subshell. L is 2 means D. So if L value is 2, that means D subshell. Got it? 3D. D subshell. So D subshell has how many orbitals, guys? 5 orbitals. Right? So 5 orbitals can have maximum how many electrons? So S subshell, remember 1 orbital. P subshell 3 orbital. D subshell 5 orbital. F subshell 7 orbital. G subshell 9 orbital. And 1 orbital can have maximum 2 electrons. Repeat, S subshell has 1 orbital, 1 ghar, 1 house in it. P has 3 orbitals. D, any shell, D subshell has 5 orbitals. F, 7 orbitals. So indeed the answer is 10. Next question. Maximum number of electrons in a subshell is given by which formula? How many electrons you can fill in a subshell? You can get it from which formula, guys? Which is the formula I just told you in the slide? Of course, 2 to L plus 1. This is the number of orbital 2L plus 1 in a given subshell, and multiply by 2 will give you the number of electrons. 2L plus 1, A part is the number of orbital. How many orbitals will be there in a subshell? They are asking you about electrons. 1 orbital can have maximum 2 electrons, right? Now the next question, how many electrons can fit into the orbitals that comprises third quant n equal to 3? if you have third shell, read the question, how many electrons can fit into the orbitals that comprise that they are the part of third shell. So how many electrons you can fill in the third shell, guys? 18, 2n square. The number of electrons in a given shell, that is 2n square. So n is the number of shell and number of electron that you can fill in any shell is 2n square. Put n equal to 3. If n is 3, this comes out to be 18. So you can fill maximum 18 electrons in third shell. Now this is the homework question for all of you. Please check and let me know the answer in the comment section based on quantum numbers, right? The quantum number which is not correct or not applicable for an electron, the options are right in front of you. Do not forget to practice quantum numbers. Super easy, super interesting, and make sure that yes, you write the answer in the comment section. Yes, math monster आरंभ का क्या हुआ, क्या होना है? आरंभ batch is going on, guys. Aditri. Okay, so just make sure that you all do this homework. And ranker batch, NSEJS ranker batch has launched. Tomorrow it is going to start. So बच्चों कल से NSEJS ranker batch 2025 targeting junior science Olympiad NSEJS 2025 start हो रहा है. तो अगर आप 2011 या 2012 born हो, then you are also eligible this year to give NSEJS junior science Olympiad, which will be in November, right? So you have enough time to prepare for this tough Olympiad exam. So we have this NSEJS ranker batch in which you will be having live sessions 5 p.m. daily, right? 2 physics, 2 chemistry, biology session 3 because the number of biology sessions are more because zoology, botany we have. So regular test, everything that can help you to crack NSEJS. If you are a part of batch, if you are following this batch, you are not supposed to use your mind ki what to do else or how can we crack. Just follow the batch curriculum. Just follow the batch plan, the best plan which has been producing results. You know VOS results in NSEJS. So batch which has been producing results from the past many years, they all students follow this batch plan. Right, guys? So how can you be a part of this batch? You can buy this batch using the code NPR Pro. You can avail this batch in 5999. Please check the description box of the video. You can get the link from where you can buy the batch, guys. So NSEJS ranker batch starting tomorrow. Start early so that you can crack the exam. Yes, Aditya, if this year you will be in 7th class, you will not be eligible for NSEJS because of the grade. Grade 8, 9, 10 student will be eligible, right? But definitely I have many students from class 7th every year. They start early because tough exam, more exposure, better chances to qualify, right, Aditya? So that is your call if you want to start early because next year you will be eligible to give the exam. And I have many students, right? In fact, IJSO gold medalist, he also started like Kanishk. He also started in 7th. He did the entire NSEJS batch in 7th itself. Okay, guys. And do not forget to subscribe our new channel for science lovers, Science Olympiad preparation. That is Vedantu Science Olympiad channel. Right? Yes. Any doubt, any query regarding NSEJS batch or anything, you can ask me. And let me share my email ID, also the Telegram group, if in case you have any doubt regarding batch or your NSEJS preparation. So this is my Telegram ID, guys. And in case you have any credential, any past credential, I can offer you the scholarship for the batch. If you have appeared in IOQM, score good, or if you have, you know, some big credential like the international rank 1 in SOF or some other Olympiad. So any academic achievement if you had, you can share with me on my email ID with your contact details so that we can offer you the suitable scholarship for the batch. This is my email ID, guys. Right? Right? Okay guys, that's all. If you have any doubt, you can ask me here also. But do not forget to follow our absolutely free Aakar batch on Vedantu Science Olympiad. Totally free batch. The best foundation batch with the most experienced faculty is going on this channel. Absolutely free daily live sessions. If you follow this batch, free batch on YouTube, 101% you can not just qualify NSEJS, but you will have a very strong foundation for your JEE NEET exam as well. Okay, bye. Take care. God bless you all. Keep learning, keep growing. And if you love science, keep on enjoying the science. Yes. Bye. Take care. God bless you all.